Okay, pre-cal babies, we are continuing in 9.2 here for our videos on Unit 9 vector notes. We need to talk about velocity. Woo woo! Okay, so velocity, of course, is the rate at which an object will change its position. So you need to recognize that velocity is a vector quantity, and when we're evaluating it, we have to keep track of the direction, and we have to include the direction when we're describing the velocity of an object. All right, so this idea of the velocity being a vector quantity, that means it's not a scalar quantity. So what do we mean by scalar quantity versus a vector quantity? Well, scalar quantities do not keep track of direction. So examples of scalar quantities, obviously, speed would be an example of a scalar quantity. Something else would be length. Something else you're probably familiar with, area, volume, lots of other things are going to be examples of scalar models. Power, work, energy, temperature, all of those are examples of scalar quantities. Vector quantities, a good example, of course, is velocity, but there are other examples, force, drag, thrust, weight, let's see, momentum, that's a good one, displacement, etc. Because these keep track of direction along with magnitude. So that's a good way to think of a scalar versus a vector quantity. All right, so keep, just as an example, let's keep this in mind. So if we're looking at an airplane that is moving west with a speed of 300 miles per hour and has a velocity of 300 miles per hour west, all right, so velocity takes into account the speed and the direction. What would a component form of a velocity vector look like? All right, so we've already talked about a component form, and we know that it looks like this. It takes into account the difference of the x component and the y component of an initial and terminal point. But how would a velocity vector component form look? Well, a velocity vector component has to look like this. It has to take into account the magnitude of the vector, and it has to take into account, and see the magnitude here, sorry, I'm losing my words. The magnitude, okay, that's going to be our speed. It's going to represent our speed for these problems. You'll see what I mean in a moment. And we also have to take into account the x value and the y value. Well, the way we do that is think of it as cosine theta. So our two values, remember when we looked at the unit circle, cosine represents the x value, sine represents the y value. So I've got an x component here and a y component. But I also am taking into consideration the speed, and this theta right here is actually the direction angle. That's why we had to learn about the direction angle. So these problems will take us a little bit more time because we have to now find the direction angle and we have to know the speed. So in order to calculate the x and the y component values of a velocity vector. Okay, I'll do the examples in another video.